Welcome back, my dear students. So in the last part of the video, I think we have discussed about the types of polymers on the source of origin and the depending upon the forces which are present between the monomers, and also how they are prepared, right? So in this segment, I think we are going to discuss about that types of polymerization reaction. We are going to discuss about types of polymerization reaction. Types of polymerization reaction. So there are two different types of polymerization reaction. One is we simply call it as addition polymerization, and the second one, that is condensation polymerization. See students, in the last class I told you, in the last part of the video, I think how the polymers are prepared. On that also there is a type of classification. In that we have discussed about addition polymerization and condensation polymerization. In addition polymerization, what will happen? Single monomer is added has to get a polymer, nothing will be eliminated. But in condensation, the small molecules like your H2O, HCl or some alcohol molecules will be eliminated. But in majority case, I think water is the elimination part. So this is all about the types of polymerization reaction. And now we are going with the first one in that one, that is addition polymerization. As the name suggests to students, here single monomeric unit is added, or two different monomers are also added. If single monomer is added, then we call it as a homopolymer, and if two different monomers are added, we call it as a copolymer. Later onwards we will discuss that one. So in this segment, and the first example that we are going to discuss is the preparation of a polyethene. Okay, for the polyethene, to note down the monomer which we are using, the monomer used is ethene molecule. You know, ethene is an alkene. Formula is a CH2 double bond CH2. This monomer is used so as to get a polymer, and the reaction is called as addition polymerization. So depending upon how you prepare this, that polyethene, and depending upon the temperature and catalyst, we have different types of polyethene. One among, we call it as low density polyethene. Low density polyethene, which is commonly called as polythene, but it is actually polyethene. So here this is shortcutly called as LDPE. The word LDPE stands for low density polyethene. And now how it is prepared? As you know, we are going to take ethene molecule, CH2 double bond CH2. How many times? N times. And simply we are going to polymerize it. And almost a temperature of 350 to 570 Kelvin we are using. 350 to 570 Kelvin you are using. And under the pressure of 1000 to 2000 atm pressure we are using, atmospheric pressure we are using, and 350 to 570 Kelvin you are using, and in presence of dioxygen or peroxide initiator catalyst, you are using dioxygen or peroxide initiator catalyst. See, whenever peroxide catalyst comes, this reaction proceeds through the mechanism of a free radical mechanism, so that you should remember. And here whenever it is converted into polymer, I think it is going to get as a CH2, single bond CH2, and on either side the chain is going to continue, and you are going N. So this itself, the name of this molecule is, you know, ethene. The name of this molecule, you know, it is called as a polyethene. So note it down here. That is what very important point. So if we are using, okay, condition apply, that if you are using the temperature of 350 Kelvin to 570 Kelvin, and under the pressure of 1000 to 2000 atmospheric pressure, and dioxygen or peroxide initiator as a catalyst, then only you are getting polythene. This polythene is now called as a low density polythene, that is nothing but your LDPE. So where this LDPE is used, coming back to its uses. See, since it is a low density polythene, it is a straight chain polymer. Okay, the major application of this is used in insulation of electric wires. So it is used in insulations of electric wires, and also it is used in manufacture of squeeze bottles, and also it is used in the manufacture of toys, and also it is used in the manufacture of flexible pipes. See, also it is used in the manufacture of flexible pipes. So this is all the way about your polyethylene. Now under the polyethylene, there is one more type of polyethylene that we almost call it as a high density polyethylene. So high density polyethylene means, obviously, as you know, catalyst temperature and pressure obviously changes, but method of preparation almost remains what? Same. So now we are going with the second one, that is a high density polyethylene. Preparation of a high density polyethylene. What might be the short form for high density polyethylene, students? It might be called as HDPE. What is HDPE stands for? High density polyethylene. High density polyethylene. How this is prepared? It is very easiest. Again, the reaction remains the same. N molecules of CH2 double bond CH2 is made to polymerize. Now the temperature we are using is almost 333 to 343 Kelvin, almost lowest temperature than the LDPE, and almost just 6 to 7 atmospheric pressure. And we are using a special catalyst called as Ziegler-Natta catalyst. We are using Ziegler-Natta catalyst. We are using Ziegler-Natta catalyst. I will tell you what do you mean by this Ziegler-Natta catalyst. It is a very important one. Here also polyethylene is formed. You know already what happens. CH2 double bond will become single bond on either side of the chain will continue, students. And how many molecules will be formed? These one, N molecules. But now the major difference is, this is as usual, you know, this is ethene only. There is no change. This is ethene, but this one is you know, it is called as a polyethylene. But which polyethylene this is? This is your HDPE, that is high density polyethylene. So that is what the difference. And coming back to the uses of this. See, I am now writing uses. Since it is very hard in nature, so these are used in making buckets. These are used in making buckets and dustbins. Okay. Then plastic chairs. This is also important. These are used in making plastic chairs, and also pipes. I think for household purpose they use for construction of pipes. So that the way the high density polyethylene is used. Then I told something about, you know, that the catalyst we call it as a Ziegler-Natta catalyst. Ziegler-Natta catalyst. This is the special catalyst that is used in the preparation of high density polyethylene. What is the composition of this Ziegler-Natta catalyst? You know, it is triethyl aluminium and titanium tetrachloride, mixture of these two. That is a triethyl aluminium. Ethyl means C2H5. Tri means thrice. Aluminium means Al. And titanium tetrachloride. Titanium means Ti symbol, you know, and tetrachloride means TiCl4. So mixture of these two is also called as Ziegler-Natta catalyst. That catalyst we are using here. See, almost in the preparation of that you are using here, you can note down Ziegler-Natta catalyst you are using, and we are preparing high density polythene. So this is all about low density and high density polythene, students. I think now it is a time for us to go for a different polymer that we are almost calling it as a third one, that is polytetrafluoroethene. The word I am using is polytetrafluoroethene. Polytetrafluoroethene, which is shortcutly called as a PTFE. P stands for poly, T stands for tetra, F stands for fluoro, and E stands for ethene, which is the most commonly used are called as a Teflon. Which is the most commonly used as what? Teflon. Which is most commonly called as what? Teflon. So you might have heard about non-stick cookwares. It is almost coated with a Teflon coating, and if you go for a bike service or a car service, in order to avoid it from the rust, they always suggest to go for Teflon coating. So monomer used here, you should remove the word poly, very simple. In order to get the name of monomer in the addition polymers, that you should all the way remove the word poly from the polymer name, then you directly get the name of a monomer. So therefore I am writing here the monomer which you are using for the preparation of polytetrafluoroethene. Can anyone tell? If you remove the word poly, what you get? You get tetrafluoroethene. See, tetrafluoroethene you are getting. This is the monomer used. See, you can check it in case of polyethene also. There the word poly removed, then you get the name of monomer, that is ethene. In polytetrafluoroethene, and here you remove the word poly, you get tetrafluoroethene as the name of the monomer. This is how we predict the name of monomer by using the name of polymer in case of addition polymerization. It applies for major of addition polymers, not for all. Majority of the polymer name, monomer name, you can easily predict by using the name of polymer in case of addition polymerization. So how this is prepared? Again, we take n molecules of CF2, double bond CF2. See, you can count 2 carbon are there, therefore it is called as ethene, and 4 fluorine molecules are there, atoms are there, therefore you can call it as a tetrafluoroethene. So how it is prepared? It is prepared with the tetrafluoroethene as a monomer, and used by using a persulfate catalyst. We are using persulfate catalyst under high pressure. Under high pressure we are using, and as you know what will happen? CF2 single bond will become, double bond will become single bond, and the chain continues on either side and becomes how many molecules? N. So this is called as a tetrafluoroethene. This is called as polytetrafluoroethene, which is commonly called as Teflon. Am I right, students? I think there won't be any preparation or a problem with the preparation of polytetrafluoroethene. And what are the major uses of it? Can anybody tell what might be the uses? I already told you where Teflons are used. It is almost used as a coating. It is chemically inert. See, the tetrafluoroethene, it is almost chemically inert. Since its inertness to the chemicals, it is almost used in non-stick cookware utensils. Almost used in non-stick utensils. Okay, this is a major application. Even in the competitive examination also, I think they ask the polymer used in the non-stick cookwares is a dash, then you have to call it as polytetrafluoroethene. And sometime they may ask you write the name of a polytetrafluoroethene monomer used, monomer name they have to ask. Then you just remove the word poly, then you get the name of a monomer. This can be done in which one? Addition polymerization. Now we are going with the fourth polymer, that is you can easily tell me now, polyacrylonitrile, which is shortcutly called as a PAN. The P stands for poly, A stands for acrylo and N stands for nitrile. So polyacrylonitrile, students, I think easily you can tell me the monomer now, because since it is also addition polymerization, I think everybody can tell me the name now. What might be the name? Who will tell me? Name of a monomer that we are using is acrylonitrile. Nitrile means, you know, CN group will be present. Acryl means a carbon-carbon double bond. That is acrylonitrile means carbon-carbon double bond with CN. So how the preparation occurs? So acrylonitrile means N molecules of, we take CH2, double bond CH, and here we have a nitrile group or a cyano group. So this will be polymerized, and the process conversion we call it as polymerization. This is polymerized in presence of a peroxide catalyst. See this, in presence of a peroxide catalyst, this polymerization reaction is carried out, okay, under high pressure. So as you know, to write the product of polymers, it becomes CH2, double bond will become single bond CH, and down you have as usual CN, and the chain continues on left and the right side as usual and becomes how many molecules? N molecules. So name of this monomer is acrylonitrile, and name of this polymer is polyacrylonitrile. This is how PAN, that is polyacrylonitrile, is used, and it is used, it is a substitute for wool. So that is also very important. Coming back to the uses, major use of polyacrylonitrile is a substitute for wool, remember, and also in making commercial fibers. In making commercial fibers, I think these are used, and also in the use it as Orlon. Use it as Orlon in the name of fibers, or you call it as acrylic. You can call it as acrylic. So these are the major uses of polyacrylonitrile. These are the major 4 different addition polymers or addition polymerization, the reaction which are given in your textbook. So in the next segment of the video, we are going to discuss about condensation polymers. I hope you liked the video, students. Thank you for your support. If you have not subscribed to the channel, please subscribe it. Thank you very much.